up, guys? In this video, we're going to be taking a look at adding and subtracting fractions. So we're going to put everything we learned in the past few videos into play here. So let's get to it. So when you're adding and subtracting fractions, you will encounter two different types of problems that, when you're doing it, maybe when you're practicing, you're doing your homework, or maybe on a test assignment. So I'll go through them each. So when you're adding and subtracting fractions, because the method we're going to use applies for both adding and subtracting, I'll show you. So when you get a situation where you have same denominators. So when you are same denominators, for example, we'll choose something like 1 over 2 plus 1 over 2. See how the denominators are the same for this one? 1 over 2, so the denominator is 2 for the first fraction, and the denominator is 2 for the second fraction. So in this case, many people would often think that we would have to add the numerator separately and the denominator separately, like this. So it would be 2 over 4, and we get half. So half plus half gives you half. Does that kind of make sense? No, right? So that's why we don't use this method in adding and subtracting. So I'll show you how it works. So when we have same denominators and it's an adding or subtracting question, or adding or subtracting problem, simple. All we have to do just draw a large fraction bar, put the 2 under, because the 2 remains the same. So when it's the same denominator, we just add the numerator. So the denominator stays the same, we just add the numerator. So 1 plus 1 is 2 over 2. So 2 over 2, we know, is equal to 1. Because we added 2 halves, so we know that 2 halves make 1. So that's explained. Same thing with subtraction. So for subtraction, we'll use a different example. We'll use this example. I know you could simplify, actually, just to make things easier for us. Because it would make it so when it's the same denominator, all we have to do, so we just put one fraction bar. The denominator stays the same. When you're adding and subtracting fractions and they have the same denominator, the denominator stays the same. We don't add the two denominators together. We only add the numerators, just to make that clear. So what is it? We add or subtract the numerators only. So the numerator here, 7 minus 3. 4 over 20, because we know 7 minus 3 is 4. 7 minus 4 and then over 20. So we can simplify this. So using our knowledge from the simplifying and the greatest common factor video, we know the GCF would be 4. So 1 over 5. So 1 over 5 would be the difference, because the answer for a subtraction question is the difference. So the difference in this case, in this question, 1/5 is the difference between these two fractions. And always remember to simplify at the end if you can. So we have looked at one scenario that you will encounter, addition and subtraction. We will now take a look at a second scenario in adding and subtracting fractions that you may encounter, where the denominators are different for each of them. So in that case, I will use just to make the things easier, we'll use this example. So in this example, 3/5 plus 6 over 15. So how would we do this? So would we do, and now in this case, would we just do like this? So 3 plus 6, 9, 15 plus 5, 20, and then simplify it? No. Which same as last time. We got it. Same as what we did in the comparing fractions. We're going to have to find the lowest common multiple. So this was what we had in the beginning. So we have to first, what we did in the comparing fractions video, we're going to have to find the lowest common multiple. So what we do first, we list the denominators only. So when we're finding the lowest common multiple, we're listing the denominators only. Sorry, I just put the brackets here. So it's 3 over 5. 3 over 5 and 6 over 15. 3 over 5 plus 6 over 15. So we put our denominators. Now we're going to find our multiples. So I'm just going to list it because I already know the answer. So okay, so it goes on. But since in this case, in this scenario, we're looking at the lowest common multiple, we don't need to go all the way down because I already know the answer. But when you're practicing, it's better, you should go up to 12 multiples for each. So you practice your multiplication table at the same time. So we listed the multiples for 5 and 15. And if you don't know what a multiple is, I'll leave the video in the description below if you haven't already watched it already. So let's get back here. So 5 and 15. We listed our multiples. So what is the common? 15. 30 is common. So these will also be common multiples if we go further on. But since we're looking at the lowest only, not the greatest common multiple, we're looking at the lowest. So lowest we know is 15. So we know that the lowest common multiple is 15. So see how we got there? So we know that the lowest common multiple between 5 and 15 is 15 itself. So if it's 15, we don't have to change this fraction. The fraction where the denominator is already 15. But let's just say this was not 15 and something else, like 6 plus, it was something different. We would have to change it to 15 or whatever the LCM was. But since the LCM is also 15, this fraction doesn't change. So we know that this fraction doesn't change, so we go back to our first fraction. So we know our denominators is 15. So I'll write it here so you guys see. So 3 times box over box gives us something over 15. So now we think, what times what gives us 15? Sorry, 5 times what gives us 15? So we'll think. We can look at our multiples things. So 5 times 1 gives us 5. 5 times 2 gives us 10. 5 times 3 gives us 15. So we know that 5 times 3 equals 15. And remember what I showed you in the last video, an important rule of thumb. What you do to the top or the numerator, or what you do to the denominator, or to one part of the fraction, you have to do that to the same on the other side. So if you do something to the bottom, you have to do the same to the top. So in this case, and that only works for multiplication and division, not adding and subtracting. That's why we're doing this. Even though the denominators are different, we have to use this method for adding and subtracting. So the rule of thumb I explained earlier. So 5 times 3 equals 15. So in order to get this from here to here, we have to multiply by 3. So we have to do it here too. So 3 times 3 is 9. So we have 9 over 15 plus 6 over 15. So now it makes it, now what do we have here? Remember the first scenario I showed you? So 9 over 15 plus 6 over 15. They're the same denominators now. So it makes life a lot easier. 9 plus 6, what we did earlier, put a big fraction bar, we put the one denominator, and then we add both of the numerators onto one fraction. So 9 plus 6, and this turns out to be 1 as well. So this is how you do adding fractions. Alright, so it was 3 over 5 plus 6 over 15, right? 3/5 3/5 plus 6 over 15. Since there were different denominators, 5 and 15, I listed the multiples for the denominators only, 5 and 15. I added them. Sorry, I found the multiples for each of them. I went up to 12. It's recommended to go up to 12 multiples when you're first doing it for practice. So 5, 15. And then I take which ones are common. I look for the lowest common value, the lowest common multiple. So the one that's least in value, and it's also common between the two denominator numbers, the 5 and 15. So I've realized that 15 is common. So I go back to my equation. So I know that 3 over 5 plus 6 over 15. 6 over 15, since our denominators already are LCM, we leave this the same. But if it was different, if it wasn't 15 and it was also a different number, we would have to do what we did here and do that there to change the fraction into 15. But since it was already 15, this fraction doesn't change. So, and then we realize 3 over 5, and then the LCM becomes a new denominator. So it's 15. So our new denominator becomes 15. So we think, what number from our existing fraction, so the fraction we originally had, the denominator, what number did we have to multiply our old denominator by to get this new LCM number that we figured out here? So using my knowledge of multiplication table, I realized 5 times 3 equals 15. So what you do to the bottom, you do to the top. So 3 times 3 equals 9. Then it becomes the same denominator example I showed in the beginning. So 9 plus 6 equals 15. 9 plus 6 over 15 equals 15 over 15. If you simplify it, you realize it's 1. You find the greatest common factor. Sorry, you simplify it, so 15 over 15 is 1. Since they're both the same, 15 over 15 is 1. So this is how you add fractions. So now, what if it was subtracting? Subtracting is the same example, same way we did it. So it was 3 over 5 minus 6 over 15 instead. Exact same way, except the number in the middle just changed. The operation in the middle just changes. So 9, it would be 9 minus 6. So 9 minus 6 is 3 over 15. And then we would have to use our knowledge of greatest common factor to simplify it. So we know that our greatest common factor would be 3. And for this one, the greatest common factor, I forgot to say earlier, we had to simplify it. If you don't know how to simplify this, we know that the greatest common factor would be 15 for both of them. So 15 divided by 15 is 1 over 1, but we can also write it as 1. So back to our other example. So we did a subtraction example to find the difference between 3 over 3/5 minus 6 over 15. 3 divided by 3, the greatest common factor is 3 between these two. 1 over 15 divided by 3 is 5. So 1/5. 1 over 5 or 1/5. Yeah, so that's how you add and subtract fractions when they have different denominators. So there's a process to that. We have to make sure that the two different denominators become the same using our knowledge of the lowest common multiple. Multiples, the lowest common multiple, and that is how we do adding and subtracting fractions. So I hope I explained this concept to you as well as I possibly could. So thank you very much for taking the time to watch this video. In the next video, we'll be taking a look at multiplying and then dividing fractions, which is actually a bit different from this. So let's get to the next video.